Hello people, IRCR Virus here, and today we're going to be looking at how to balance chemical equations. If you have any questions by the end of the video, just drop your questions in the comments below. And if you like what you see, well, like and subscribe. So let's just get into it.
It was a nightmare.
Activate.
How to balance chemical equations step by step, and I'm going to show you my method, and then you can decide whether it's easier for you or not. Okay, so first of all, what we got to do is that we got to count the atoms in each side of the chemical equation. Then we're going to make the small numbers equal to the big ones, and we're always going to start balancing hydrogens, oxygens, and then anything else. Okay, so the first example what we got here is we got hydrogen and oxygen to make water. Okay, so in a water equation it will look like this: hydrogen plus oxygen gives you water. However, we can see that it's not balanced because you have two hydrogens and two hydrogens over here after the arrow, two oxygens and one oxygen. Therefore, if we look at the chemical equation, if we add another water particle, you have four hydrogens and two oxygens. You got two oxygens and four hydrogens. So what do I have to do now? I'm gonna make sure that I have the same amount of hydrogens in both sides. So we're gonna add two more hydrogen molecule to atom, another hydrogen molecule. So each one of those represents an atom, and all of them, that will be one molecule, that will be one molecule. So now we got four hydrogens in the reactants, we got four hydrogens in the product, two oxygens in the reactants, and two oxygens in the product. So, but how do we get there? Okay, so the first step, we've got to count how many atoms there are in each side of the chemical equation. Okay, so there we go. Anything before the arrow and anything after the arrow is what you're looking for. Okay, so you got hydrogen, hydrogen, oxygen, oxygen, two hydrogens in this side, two hydrogens in that side, two oxygens and one oxygen. So what we got to do is gonna make the small number equal to the big ones. There we go. So the one has to be equal to the two. So always start balancing hydrogens, oxygens, then anything else. At the moment, the hydrogens are balanced, so we're gonna skip them and we're gonna go straight to the oxygens. Okay, so if we multiply that oxygen times 2, we're gonna have two oxygens in the products, and then we have two oxygens in the reactants. However, because that hydrogen is also part of that same water molecule, it's also gonna be multiplied times 2. Therefore, we have four hydrogens in the product and only two in the reactant. So we gotta make the small number equal to the big ones, and that means that we're gonna put a 2 over here and multiply it by the hydrogens, and now we got the equation balance: four hydrogens, two oxygens, and two oxygens as well. Now, how to balance the chemical equation? We're gonna go for example number 2. Right, so again, count the atoms on each side of the chemical equation. So in this case, we have aluminium and oxygen to make aluminium oxide, oxygen, oxygen, aluminium, and aluminium. So two oxygens, three oxygens, one aluminium, two aluminiums. Okay, right, so let's see. Make the small number equal to the big ones. Now over here we have a tricky situation, because it doesn't matter if you multiply this one by 2 and that one by 2, or this one by 3 and that one by 3. You're always gonna have a difference, because this is a pair number and this one is an odd number. So what I tend to do is that if they are the same element, I tend to swap those around. So I'll multiply the one in this side by 3 and I'll multiply the one in that side by 2. Alright, so small number equal to the big ones. Start with hydrogens. We don't have any hydrogen, so we're gonna start with the oxygens. There we go, 2 over there. That's the 2 that comes from this side, and the 3 that comes from this other side over there. Okay, so we got 2 times 3 equals 6, and then we got 3 times 2 equals 6, and now our oxygens are balanced. However, because this aluminium is also part of this aluminium oxide molecule, what you're going to have to do is they're gonna multiply that one times 2 as well, and that gives us a 4. So make the small number equal to the big ones, make that 1 equal to 2, so we just gotta multiply it times 4 equal to 2. I say equal to 4, and gotta multiply it times 4. Okay, so that's what we got there: 6 oxygens, 4 aluminiums, 4 aluminiums, and that's how that one is done. Now we're gonna do one more example number 3. Count the atoms in each side of the equation. So in this case we got something slightly more complex, and we have hydrogens, 1 and then 2, and this is because of that. What I tend to do is that I put on this hydrogen here, and that hydrogen, I kept them separate. I didn't just add them all in one, because you're gonna have a little bit of difficulty after when trying to multiply them, and if you make a mistake, this is a lot easier to spot where the mistake was. Okay, now on that side we got 2. They come from this hydrogen over here, from the water molecule, And then we have oxygens, 3 in that side, 2 in that side. And remember that even in normal maths, whatever is inside the bracket gets multiplied for whatever is outside the bracket. So in this case, that 2 times 1 equals 2, and that's why we have a 2 there. And then the 2 times 1 equals 2, and that's why we have another 2 oxygens here. So we got 3 oxygens from there, and you got 2 from the other molecule, okay? So there we go, we got 6 hydrogen oxygens over here. 2 times 3 is 6, and then we have the 1 oxygen from over there as well, okay? So nitrogens 1, 2, because it's being multiplied, and then we have calcium 1, calcium 1. Now make the small number equals to the big ones, and this is what we got, that, and that. Now hydrogen, oxygens, and then anything else. So hydrogens, we got 3 in one side, 2 in the other side. So what I will do, I'll put 2 here, multiply that, and it gives us 4. Put 2 over there, multiply that one there, and it gives us 2. So now we have 2 here and 2 here equals 4, and we got 4 straight away from here. Now hydrogen seems to be balanced, okay? Then, because that oxygen is also part of the water molecule, it's gonna be multiplied times 2 as well. Notice that I multiplies this 1 oxygen, not the whole thing, and this is the reason why I like to keep them separate, because if I written down 7 oxygens, then that might create a little bit of a confusion. And then that one there, obviously that oxygen also is part of that molecule, so it's going to be multiplied times 3, and if you can see here, there's a little 3 here, and that 3 means that there is 3 oxygens in this whole molecule. Right, so that's what we got there. Now we got 8 oxygens in one side, and we have 8 oxygens on the other side, so everything seems fine, everything seems to be balanced. However, we also have that 2 multiplying this nitrogen, and that's why that nitrogen is gonna be 2 as well. And in this side we already got 2 nitrogens because it was being multiplied by whatever's outside the bracket. 4 hydrogens, 4 hydrogens, 8 oxygens, 8 oxygens, 2 nitrogens, 2 nitrogens, 1 calcium, 1 calcium, okay? And that's what we got there. Now, there's a couple things we gotta keep in mind when balancing equations. Number one is that you can only add big numbers to the left of the molecule. So every time you see a molecule written down, you can only add big numbers to the left, okay? And that number will multiply everything else. Then the big number that you add will multiply every element, every uppercase that you see there, okay? So 2 times hydrogen, 2 times nitrogen, 2 times oxygen, but remember that the oxygen has got a little 3 there, and that 3 means that you will never add one of those small numbers to the right of the molecule, because it tells you how many atoms of that specific element there are in that molecule, and the small number tells you the number of atoms of that element right next to it, in this case oxygen. So if you avoid that 2 there, what you have is 1 hydrogen, 1 nitrogen, 3 oxygens, but because we got a 2 there, it means that we got 2 sets of that. So now altogether you will have 2, 2, and then 6. Following from that, the big number to the left of the molecule will not multiply past the plus sign, okay? So in this case, 2 multiplies everything up to here. Anything after the symbol has nothing to do with it, okay? So it won't affect anything else after that, because that will be a whole different molecule. The small numbers to the outside of the bracket of the molecule will only multiply the elements inside the bracket, okay? So this is not like we did before. This 2 is only going to multiply whatever's inside the bracket, and it won't touch the Ca, which is the calcium, okay? So 2 times 1, 2 times 1. If this had a little 3 there, then will be 2 times 3, and so on, like we saw in the example before. And the big numeral at the top, if the big number is on the left of the molecule, it will multiply everything, including what is inside the bracket. So over here we got the calcium, it will multiply we multiply by the 2, and we'll also multiply everything inside of it, okay? So the little 2 on the outside can only multiply the stuff that is inside the bracket, but the 2 over here can multiply only, well, not only, but we'll multiply everything all together, okay?